Hello, class. I am trying once again to put up the video for your lesson on visible light. So we are going to be talking about where does visible light fall on the electromagnetic spectrum? How does an object's material and the light's frequency or color affect the way light is reflected, absorbed, and transmitted? And how does the frequency of a light wave determine the color of the light we see? We will also discuss a little bit about how primary colors of light produce secondary and complementary colors, and how amplitude of a light wave determines the brightness of the light we see. So, first of all, I have told you that light waves are electromagnetic waves. And next week we're going to start discussing in depth the electromagnetic spectrum. So there are a lot of electromagnetic waves, and visible light is just that section of the electromagnetic spectrum that we are able to see. And visible light falls between infrared rays and ultraviolet rays. If you remember from our discussions about wave structure, shorter waves, or waves with a shorter wavelength, have a higher frequency and therefore have more energy, whereas longer wavelengths give us waves with lower frequency and thus lower energy. So this visible light spectrum that we are talking about is produced when light passes through a prism. So if you pass white light through a prism, the prism causes the white light to refract or bend, and this slows each of the individual wavelengths down into their separate colors. So white light is actually a combination of all of the different colors of visible light. And those colors are from least energetic to most energetic: red, orange, yellow, green, blue, indigo, and violet. And you can remember that and remember the order by remembering the phrase or name Roy G. Biv. So each of these wavelengths of visible light we see as the colors of the rainbow. Each color has its own individual wavelength and frequency. So if you look here, you see that red has the longest wavelength, which means that it has the shortest frequency. So red is actually the least energetic color, whereas violet has the shortest wavelength of the visible light spectrum and therefore the highest frequency. So violet is the most energetic of the colors in the visible light spectrum. When we see all of these colors together, we see them as white light. But again, white light can be refracted by a prism and split into its individual wavelengths, its individual colors. And this is what happens when we see a rainbow. When there's a lot of moisture in the air, white light from the sun comes down, and all of the individual droplets of water and water vapor in the air act like prisms and splits the white light into its individual wavelengths, giving us a rainbow from least to most energetic, with red on top and violet on bottom. So, in order for any object to be seen by us, it either has to produce light on its own or it has to reflect light. So, some examples of objects that produce their own light would be the sun, a candle, a flashlight. Objects that we see because they are reflecting visible light would include the moon, which does not produce any light of its own. It only reflects light from the sun. We see reflections in mirrors because they're reflecting light, and we can often see glass, even though it's transparent, because some of the light is reflected off of it. So when we are talking about how we see objects and how light reflects off of objects, we have to talk about the opacity of the material. So when an object is completely opaque, this material will either reflect or absorb all of the light that strikes it. So no light at all can go through the material. So this would include materials like wood, metal, cardboard, people, things like that. So if an object is transparent, that's the complete opposite. Transparent materials are able to transmit all of the light that hits them. So all of the light that hits them is able to go through. It may be refracted, but it will go through. So transparent materials would include glass, water, and air. A translucent material scatters light that passes through it. So not all of it is reflected or absorbed, but not all of it goes through either. So think about something like wax paper or frosted glass, for example. So when we talk about light, we have to remember that light always travels in straight lines. But this straight line motion can be reflected, diffused, refracted, absorbed, or diffracted. And we're going to talk about these different behaviors. So reflection occurs when parallel rays of light hit a smooth surface. So the light comes in, it hits a smooth surface, and all of the rays of light that hit that surface are reflected at exactly the same angle. And if you remember, we have talked about the law of reflection, which states that the angle of reflection is always equal to the angle of incidence. So whatever angle the light rays come in at, that is the angle they will be reflected at. And the angle of incidence is the measure of the angle of a ray to the surface normal. That's perpendicular to the surface. So diffusion is really just a type of reflection, but it's a type of reflection that occurs when light hits a surface that isn't smooth, that's bumpy or rough. So when light rays hit a surface that is bumpy or rough, each of those rays obeys its own law of reflection. So since each ray is hitting a different bump, which is angled differently, each ray gets scattered in a different angle of reflection. so the light gets scattered or diffused. Refraction is when light waves enter a new medium at an angle, and entering this new medium changes its speed. And if you remember, we have talked about in class that for light, the more dense the medium, the more the light gets slowed down. So this change in speed causes the light waves to bend or change direction. And the index of refraction is a measure of how much light rays are going to bend when they enter the material. And this bending of light is what causes us to see a straw or a pencil in a cup of water look kind of broken or bent. And this same refraction is also what causes prisms to scatter white light into its individual wavelengths and colors. So another aspect of refraction that I'm only going to cover very briefly because we're going into it more next week is with lenses. And this is the principle behind magnifying glasses, eyeglasses, microscopes, telescopes, and everything like that. So when light is traveling in straight parallel lines and it passes through an object that is curved, the light is refracted at different angles. So you can have a convex or a concave lens. And depending on whether you have a convex or a concave lens, the light is going to be bent towards a central focal point or outward. And like I said, we'll be going more in depth into lenses next week as we continue our unit. The last thing I want to talk about, and it's not on your notes, so I need you to put it on your notes somewhere off to the side, whatever. And I'm just going to let this be your Easter egg. If you have diffraction in your notes, I'll know that you actually watched the video. So diffraction is the slight bending of light as it passes around the edge of an object. So this is light bending around something. And one of the main ways that we see this with light is when light goes through a small space, and as it goes around the edges of that small space, it starts to spread out. Just like light going through a keyhole and spreading out. So lastly, we have absorption. Absorption is when light doesn't pass through or reflect from the material at all. It remains in the material as energy. And when this happens, usually the material heats up because light energy transforms into thermal energy. So the more light an object absorbs, the darker it appears to be. So if an object absorbs all the light, it will appear to be black. So I'm going to very briefly discuss color. So colored objects reflect certain wavelengths of light. So we see objects as their reflected color, their reflected wavelength. So we've talked about the different colors of light: red, orange, yellow, green, blue, indigo, violet. The primary colors are red, blue, and green. When they are combined in equal amounts, primary colors produce white light. If combined in varying amounts, they can produce any other color you would like to make. So secondary colors are yellow, cyan, and magenta. Primary colors combined in varying amounts will create these different colors and shades thereof. Complementary colors form when a primary and a secondary color combine to make white. So red and green make yellow, and then when you add blue, you then get white light. Green and blue combined with red will make white. Red and blue make purple, combined with green again make white. And I'm running out of time, so I gotta go, guys. I will talk to you later. See you in class.